Okay, I have mentioned, and I taught this course I taught calculus for a long time, but this particular course at GCU for a number of years. And I'm not an economic major or business major or anything like that. So some of these terms, are kind of learning for me, or just something that's somewhat novel, or I don't have that much depth in terms of the whole economic theory and so forth. But as far as the analysis, well, that's I guess where I come in. But so anyway, this idea of elasticity, is basically is talking about price and demand interacting, for a particular product, and they kind of get into this, and I'll let you read this part. It is from your textbook here. But ultimately, we're going to be working with this equation, which gives us we define what elasticity is, and then it also a way of determining that it is a numerical value. And the key number here, I guess, is one that we're working with here. In other words, um, this value of E being equal to one is kind of an optimal situation here. We call that, I'm assuming that's the case here, in terms of economics and so forth. But so that term is, I guess, unit elasticity. If the demand, and again, this is in terms of the demand of a particular product here. If E is greater than one, then we say it's elastic, and then if we say it's less than one, it's inelastic. Okay, so what do those terms mean? Well, I basically highlighted that down here. And if E is less than one, the relative change in demand is less than the relative change in price. Okay. And if we go the other way around, and if the demand is, and we call that inelastic, okay? And again, that's if E is less than zero. If E is greater than one, then the relative demand is, change in demand is greater than the relative change in price. We call that elastic, okay? And so, basically they summarize it here, and I highlighted that, if it's inelastic, it means a small change in price has little effect on the demand. Whereas if it's elastic, a small change in price has a more of an effect on the demand. And then when we're right at one here, we just say the percentage price, changes of price and demand are relatively equal. Okay. So, depending on what the situation is and what you're manufacturing and selling and all that sort of stuff, like I said, we'll leave that to you business majors. But, we're going to get into determining how do I determine that number here. And it's essentially, we're just using this. I also want to point out that in order to understand how I find the derivative here, you should have already gone over how to, what implicit differentiation is, and, how to do that. And this one here is, relatively simple. So, all right, so that's kind of the backdrop here. And what I got here is kind of a little bit of a wavy when I made my scan here. I'll just come over here, and I should have probably, let me just slide this out of the way here. Move on to the problem here we're taking a look at. Okay, so here's something from my math lab here for the following demand function. Okay, and Q is going to be the demand, and the P is going to be the price. Okay, so we given an equation here. And all we're really going to do is I wrote the equation down for E is equal to negative P over Q times dQ dP. And what that is the derivative of Q with respect to P. Now remember, we're talking about an instantaneous rate of change here for a derivative, right? It's the instantaneous rate of change of the demand relative to the change in the price here, okay? And so if I take the derivative of dq dp here, or okay, and that is a q, not a g. So dq dp would be equal to, and this derivative is zero. And since I'm differentiating with respect to p, it's just going to be really, I'd look at this as negative 1/2 times p. So I'm just going to get negative 1/2. That's dq dp. So here's the original function. I apply implicit differentiation. I find dq dp over here to be equal to 1/2. And now all I'm going to do is just substitute right into this simple equation here. So dq dp gets replaced with the negative 1/2. P is obviously P. And what I'm going to do is I'm going to get everything in terms of P. So what I do with that is I just solve over here for Q, excuse me. Okay. So Q is already solved for. So I'm just replacing Q here with this expression 44 minus P over 2, which you can see that I do here. Now, all I'm doing is simplifying here. So if I multiply these two things together, I have a negative times a negative. So I'm going to get a positive. And the 1 times P is just going to give me P. And I distribute my 2 through the denominator. So 2 times 44 is 88. And 2 times P over 2 is just going to give me P because the 2's will cancel out. So this is my equation for E, okay? And that is the first part here. They're asking us, what is my equation for E? Okay, so again, all I did was substitute the values in for dq dp. I replace q with the given equation here, and I just simplify, and that's how I end up with E here, okay? Now it says state it says in part B here, number one, it said find E, which we did do, the values of Q, if any, in which the total revenue is maximized. And that is basically when we get E equal to 1. So all I do is I take my equation here and I replace the E with 1, okay? I solve for P, okay? I get P equal to 44, but they want, again, the values of Q, okay? So all I need to do for Q is once I find P, right, that gives me the revenue being maximized when P is equal to 44. All I do is just go back to this simple equation and substitute the 44 in for P, and then I could get my value of Q, which is 22, and that's what I would type in there, okay? So again, I know I went over that relatively quick here, kind of jumps around, you're going back to equations and substituting in. Again, obviously use the pause and scroll for, the replay stuff so that it makes sense to you. But, again, summarizing that, all I'm doing here for the first part is just computing the dq/dp using implicit differentiation, getting an equation in terms of P. Then I want to find the value of P that makes E equal to 1. So I'm just using some basic algebra there, okay? And I get that value for P to be equal to 44. But they want the value of Q, okay, in order to come up with the solution for this problem here. And so I'm just going to go ahead and pop that in for when P is 44. Q is going to be equal to 22. How do I know that? I just substitute into my original equation, and then I type that answer in, okay? So some of these might be a little bit more difficult in terms of, finding the derivative and so forth, but overall, they're not too bad. And, you got that help feature on the My Math Lab to kind of fight through the calculus part of it. But I wanted to at least do one video to kind of give you the overview of the problem without getting bogged down into finding, a complicated derivative and that sort of thing. So. All right, there we go. There's your example for elasticity, and we will see you in the next video.